What should we expect when a massive supergiant star explodes in our immediate neighborhood? The James Webb Telescope's new discovery about the Betelgeuse supernova is giving scientists cause for concern. We may have been very wrong about the red giant star. Does this mean that we on Earth will soon have to reckon with the explosion and effects of the supernova? The James Webb Space Telescope has shown us several times in recent months that our scientists are wrong. In the case of a supernova, such an error could have fatal consequences. Betelgeuse is a red supergiant star. For centuries, the star has been visible in a prominent position in Orion's shoulder. It shines red, which we can even see with the naked eye on Earth. One thing is certain: Betelgeuse will explode, and soon on a cosmic scale. It will happen sometime between now and a few thousand years from now. Since Betelgeuse has been behaving increasingly strangely, scientists have been debating about what is correct and where huge errors may have crept in. Is Betelgeuse already on the path to supernova? Or is the aging star just having a temporary phase of instability? In 2019 and 2020, strange eclipses occurred, leading some scientists to speculate that the star was about to explode. Others waved it away, saying that these events had nothing to do with the star's actual condition. So what is true? Betelgeuse is a huge star that outshines our Sun by a factor of 1,000. If we were to place it in the center of our solar system, it would reach beyond the orbit of Jupiter. Betelgeuse was not always so large. It has only expanded since it used up its fuel supplies. This growth in size is due to the progressive depletion of its fuel supply. In its core, the star fuses hydrogen into helium and later into heavier elements. As soon as the hydrogen in the core is used up, the star begins to shed off its outer shells. This leads to an increase in its diameter and fluctuations in brightness. So, how do we determine what stage the star is actually in? On the one hand, our observations refer to data from other supernovae, but this has its pitfalls as these events are very rare. Thanks to telescopes, we could already observe supernovae in other galaxies or other corners of our own galaxy. But as is the case with Betelgeuse, no two are the same. Is Betelgeuse dangerous for Earth? Did you know that Betelgeuse could have already exploded, and we have not noticed a thing? Because the star is around 700 light-years away from us, in practical terms, this means that its light takes 700 years to reach us. If the star exploded, we wouldn't see it until 700 years later. Supernovae eject large amounts of matter into space and produce radiation that can be devastating. But despite the violence of these events, researchers are certain that none of these ejections will reach us. However, we are not completely unaffected. Violent portions of matter, such as burning shreds at the surface or dense gas, are lost over the distance of 700 light-years. There are other particles and radiations for which this distance is almost negligible. These include neutrinos, which could be with us before we even see the light. Neutrinos are relatively newly discovered particles in astrophysics, also known as ghost particles because they easily penetrate matter. Neutrinos are all around you now in nature and in the cosmos, but practically we know very little about them. We have only been detecting neutrinos for a few years using special facilities in Japan and Italy, among other places. However, Betelgeuse shows us something that can be worrying. We are far from knowing all types of particles, radiations, and phenomena. It is practically rare for a supernova to have exploded right in our cosmic neighborhood. It is therefore important for us to know what else will be hurled into the air by such an event. Another pitfall is we don't know for sure how far away Betelgeuse really is from us. Measurements from the distance between the Earth and the red giant star have always produced slightly different results, and all astrophysical measurement methods are currently under scrutiny. The old physics has had its day, and some crazy observations by the James Webb Space Telescope are responsible for this, showing us in a bitter way how often they are wrong. What if such an error is also present in the assessment of the situation around Betelgeuse, and we are in danger after all? The scientists are debating, is it going to explode or not? It is fascinating, or even frightening, how differently scientists perceive the behavior of Betelgeuse. The great eclipses of 2019 and 2020 were ultimately explained by a massive ejection from Betelgeuse's surface into the universe, creating a dense cloud of dust that darkened the star for weeks. We are familiar with such phenomena from the Sun. However, coronal mass ejections from our Sun are much smaller and do not usually produce such massive clouds. Our Sun is also still a star in its midlife and not an aged star like Betelgeuse. Some scientists have likened Betelgeuse's ejection to an old man's cough. Betelgeuse took months to recover from this event, and some believe that such unusual events could mean that the star's end could come sooner than expected. It is not uncommon for Betelgeuse to go dark. The star has two well-studied cycles within which it operates. However, the 2019 event and the subsequent 2020 eclipse occurred outside these cycles. It is suspected that there may be a third cycle spanning several thousand years that we did not know about until now. However, we must not assume that everything in the universe is always predictable. In such a way, the ideas of our researchers are confirmed. We must always expect surprises and also that Betelgeuse will explode much sooner than assumed. The most widely accepted estimates currently assume an explosion in the next 1,000 to 100,000 years. In this context, however, recognized does not mean true. A Japanese team of scientists presented a credible and well-studied study that caused a stir in the world of science. According to the study, the disturbances on Betelgeuse's surface could be interpreted in a completely different way, and the time to explosion could be significantly shortened. This team has argued that unexpected behavior of massive stars like Betelgeuse can be evidence of decay processes in the final stage. Betelgeuse's core collapse would be imminent. Betelgeuse gets heavier and theoretically collapses. We know very well how a star works theoretically. Betelgeuse was once very likely a massive star that began its life as a hot and main sequence star. In the center of such a star, nuclear processes take place in which hydrogen first fuses to helium. This fusion releases enormous amounts of energy that keep the star stable for millions or billions of years and prevent it from gravitational collapse. At some point, the hydrogen supply in the core is used up. Then, the star begins to fuse heavier elements. During each of these phases, the star continues to expand as the energy from the fusion pushes the outer layers of the star outward. Betelgeuse is in this phase and has expanded into a red supergiant star. This bloating is a clear indication that the star has largely used up its fuel reserves in the core. The crucial point in the evolution of a massive star like Betelgeuse is the end of fusion. Once the core consists mainly of iron, no more energy can be produced through fusion. Iron fusion consumes more energy than it releases, which is why the fusion process stops. Without energy production through fusion, the star loses its equilibrium. The gravitational pressure, which was previously balanced by the energy from fusion, then leads to a collapse of the core. Within moments, the core collapses under its own gravity, reaching extreme densities and temperatures. This collapse creates a shockwave that races through the star and hurls the outer layers into space at enormous speeds. This is the supernova explosion. When a supernova explodes, an incredible amount of energy is released, causing the star to shine brighter for a few moments like in a galaxy. The energy released exceeds the total energy produced by our own Sun in its entire life. The outer layers of the star are hurled into space. What remains at the end is the core. The star can either further collapse and become a neutron star or, in the case of even more massive stars, a black hole. A neutron star is an extremely dense object in which matter is so compressed that protons and electrons fuse to form neutrons. Such a star has incredibly high density. If the remnant is even more massive, it collapses further into a black hole, a region of space from which not even light can escape. The exact nature of the remnant depends on the original mass of the star and the details of the explosion. The spectacular death of Betelgeuse will be an impressive astronomical event and will give us valuable insights into the processes at the end of the life of massive stars. It will mark the end of an era for one of the most famous stars in the night sky and herald the beginning of a new phase in the study of supernova physics. Discover many more exciting videos on the channel now. Betelgeuse, one of the most luminous stars visible to the naked eye in the constellation Orion, has captivated astronomers and stargazers alike for centuries. Its distinctive red hue and prominent position have made it a celestial icon, but its evolutionary journey holds even greater fascination and scientific intrigue. Located approximately 700 light-years away from Earth, Betelgeuse is classified as a red supergiant, a phase in the life cycle of massive stars characterized by its immense size and unstable nature. This stellar giant has expanded to such proportions that, if placed at the center of our solar system, it would engulf the orbits of Mercury, Venus, Earth, and Mars, extending beyond even Jupiter's orbit. This staggering size underscores the colossal scale of Betelgeuse and its prodigious mass compared to our Sun. Betelgeuse wasn't always the behemoth it is today. Like all stars, its existence began in a tumultuous dance of nuclear fusion within its core. Born from vast clouds of gas and dust, the star ignited into a fiery sphere where hydrogen atoms fused together, releasing energy in the process. This fusion process, known as stellar nucleosynthesis, transformed hydrogen into helium, fueling Betelgeuse's brilliance and sustaining its equilibrium against the relentless pull of gravity. However, stars like Betelgeuse are voracious consumers of their nuclear fuel. Over millions of years, the hydrogen in its core began to deplete, leading to a series of cascading reactions that transformed Betelgeuse's internal structure. As hydrogen fusion waned, helium became the primary fuel source, fusing into progressively heavier elements such as carbon, oxygen, and silicon. Each successive fusion stage produced less energy and lasted for shorter periods, contributing to the star's evolutionary instability. The depletion of hydrogen marked a critical turning point in Betelgeuse's life. With its core now composed mainly of inert helium, the star's internal dynamics shifted dramatically. The core's inability to sustain fusion reactions meant it could no longer generate sufficient energy to counterbalance the inward gravitational force. This gravitational collapse initiated a sequence of events that would ultimately lead to Betelgeuse's spectacular demise: a supernova explosion. Supernovae are cosmic cataclysms of incomprehensible power. When a massive star like Betelgeuse exhausts its nuclear fuel, the core collapses under its own gravity with staggering force. This collapse releases an immense burst of energy, triggering a shockwave that rips through the star's outer layers at speeds exceeding millions of kilometers per hour. The resulting explosion can briefly outshine an entire galaxy, emitting more energy in mere moments than our Sun will emit over its entire lifetime. For astronomers, the prospect of observing Betelgeuse's supernova presents a rare opportunity to study these cataclysmic events up close. Supernovae are crucial to our understanding of the universe's chemical enrichment, as they scatter heavy elements forged in their cores across the cosmos. These elements, crucial for the formation of planets, stars, and even life itself, are dispersed into interstellar space, where they eventually coalesce into new celestial bodies. The aftermath of a supernova is equally profound. Depending on its mass, the remnants of Betelgeuse could form a neutron star or even collapse further into a black hole, a region of space so gravitationally intense that not even light can escape. Neutron stars, formed from the cores of massive stars, possess densities so extreme that a single teaspoon of their material would weigh billions of tons on Earth. These remnants serve as cosmic laboratories for testing the limits of physics under conditions impossible to replicate on Earth. Despite Betelgeuse's cosmic significance and the scientific wealth it promises, its potential to impact Earth remains negligible due to its immense distance. Light from Betelgeuse takes approximately 700 years to reach us, meaning that any explosion observed today actually occurred centuries ago. This vast distance ensures that the radiation and debris from Betelgeuse's supernova, while awe-inspiring in cosmic terms, pose no direct threat to our planet or solar system. Yet, the journey to understanding Betelgeuse's fate is fraught with uncertainty. Astronomers' ability to predict when Betelgeuse will explode is limited, as supernovae are rare and their timing unpredictable. Recent observations have shown fluctuations in Betelgeuse's brightness and surface dynamics, leading to speculation about an imminent explosion. However, these fluctuations could also signify transient phenomena within the star's complex atmosphere, challenging scientists to distinguish between routine stellar activity and portents of impending cataclysm. The James Webb Space Telescope, slated to be the most powerful space observatory ever launched, promises to revolutionize our understanding of Betelgeuse and other celestial phenomena. Its advanced capabilities will enable astronomers to peer deeper into the universe, unraveling the mysteries of stellar evolution and providing unprecedented insights into the life and death of stars like Betelgeuse. Beyond its scientific significance, Betelgeuse holds a cultural and historical importance that transcends scientific inquiry. Known since antiquity and referenced in countless myths and legends, Betelgeuse continues to inspire wonder and curiosity about our place in the cosmos. Its eventual supernova, when it occurs, will mark a transformative moment in human history, offering a profound reminder of the universe's immense scale, beauty, and enduring mysteries. In conclusion, Betelgeuse stands as a cosmic beacon, illuminating the boundaries of human knowledge and inviting exploration into the nature of existence itself. Its journey from stellar birth to impending supernova encapsulates the grandeur and volatility of the universe, challenging us to embrace uncertainty and embrace the quest for understanding that defines our shared human experience.